On Mount Olympus in southwest Turkey, the rocks spout flames. Flames literally come out of the ground. This has been known since antiquity. Ancient sailors used the region for navigation. The original Olympic flame was lit from these fires. When people got around to looking what is the gas that comes out of the ground and burns, they discovered it's hydrogen. 5,000 miles away in Los Fuegos Eternos in the Philippines, flames again spout a foot out of the ground. And again, when we looked at the composition of the gas that was burning, we find it's 50% hydrogen. But the events that really stimulated the activity around so-called natural hydrogen happened in Mali in North Africa towards the end of the in 1980s. In 1983, villagers there drilling for water drilled a well that was about 110 meters, and it exploded. They assumed that they drilled into natural gas, and so they plugged the well. In 2014, people went back and unplugged the well to start extracting the natural gas, and very quickly discovered it wasn't natural gas. It was hydrogen, pure hydrogen, pure hydrogen. Since that time, 25 additional wells have been drilled around the region in the same reservoir, and hydrogen flows from all of those wells. Today, they use that hydrogen for electricity. In retrospect, it's really not that surprising that hydrogen would come out of the ground. The earliest reference that we can find in the scientific literature to hydrogen coming out of the ground is in the 1880s, when people observed it leaking from cracks in coal seams. There was a large discussion in the scientific literature in the 1970s and 1980s about the origin of abiotic oil. We knew for a long time there's a whole bunch of oil that doesn't come from decaying organic material. We knew that from isotopic analysis. So where does it come from? And the consensus was it was the reaction of hydrogen and CO2 in the ground to produce that oil. And around the world in various places, in Australia, in Brazil, in eastern North Carolina, these so-called fairy circles turn up. These are circular depressions in the ground, often near water, and from the periphery of those fairy circles, hydrogen is emitted. So we've known hydrogen comes out of the ground for a long time. So why does this matter? Why do I care? Hydrogen is pure reactive chemical energy. If I have enough hydrogen and it's cheap enough, I can do anything. Hydrogen is the Swiss Army knife of energy. I can make materials, I can make steel, I can make fuels. We even had fun playing around. You could make food at cost-competitive prices if your hydrogen is cheap enough. So how cheap is it? Well, estimates are that hydrogen at the wellhead from this natural hydrogen will be on the order of $1 a kilogram or less. It's extraordinarily low cost. And is there a lot of it? The origin of this hydrogen is still a little bit under debate, but most people, I think, believe that it comes from the reaction of iron-2 and water. If that's true, you're limited only by the amount of iron-2 in the Earth's crust. And that number is effectively infinite. Jeff Ellis at the United States Geologic Survey has estimated that the accessible resource may be as large as 1 trillion tons. 1 trillion tons of hydrogen is enough to power all of humanity for thousands of years. So there's a lot of work left to be done. How do we get it out of the ground? How do we find it? All of those kinds of things. But make no mistake, this is the most important discovery in energy in our lifetime, and probably the most important discovery in energy in our children's lifetime.